In this video, we're just gonna do a bunch of substitution examples because there's always these little quirks and stuff that you're looking for as you're doing problems. All right, so skip through this as much as you need to. All right, if you feel like you're comfortable with doing substitution and you're ready for class, you don't need to watch the whole thing, or you can, watch it all if you're still kind of struggling with where does this u come from and how do you simplify. Again, just like the chain rule, you know you're doing the chain rule when something's inside of something else. So here, right away, I see this and I say, well, there's this square root that's pretty complicated, and u should be x squared minus 5, this thing inside the square root. If that's true, then du is 2x dx, and du over 2x equals dx. All right, so now I'm going to rewrite this. All right, x squared minus 5 becomes u. Dx becomes du over 2x. Here, a little bit different than our last video, here the x's cancel, but this 2 does not. But that's perfectly fine because the 2 is just a constant multiple. So this 2, which is actually a 1/2 because it's on the bottom of this fraction, can just come out in front of the integral. Like that. All right, so it's fine if not everything cancels out as long as all the x's cancel out. All right, so there's some extra numbers and stuff left over. Just put those in front of the integral. It won't really change anything. All right, this one, it's helpful to rewrite whenever we're doing derivatives and integrals. All right, it's helpful to rewrite our square roots as an exponent. So now I know that when I take the antiderivative, I add 1 to the exponent, then divide by that new exponent. And when I multiply these 2's are going to cancel. It's going to be 1/3 u to the 3/2 plus c. And then my very last step, one that students forget sometimes, is you have to remember that our original question was about x. So I finish off by just doing x going back in for u to finish the problem. All right, now we have trig functions getting involved. This one, it's not obvious. There's nothing inside these x's, so it's not completely obvious what u should be. But always remember that these shortcut notations for the trig functions can be a little confusing. And this actually means this. All right, so now you can actually see that cosine of x is in these parentheses with this exponent. So I'm going to try u equals cosine x. I noticed I just said I'm going to try because sometimes you pick a u and it just doesn't make the problem simpler. It doesn't work out. All right, so you won't always know right off the bat what u should be, but don't be scared to try things. Du is going to be negative sine of x dx, divide by negative sine. And so now my integral is going to be sine of x over u cubed. Dx is du over negative sine of x. And my choice for making u cosine of x worked out because the things with the x's cancel out. I just have this extra negative sign here, so that negative sign that hasn't gotten canceled out, I'm just going to put it at the front. 1 over u cubed du. All right, for this one, I'll remember that, again, I don't like fractions when I'm doing antiderivatives. It makes it really hard. So instead of a fraction, I'm going to write this as u to the negative 3. All right, our negative exponent rules. And then I can do this as add 1 to the exponent. It's going to become u to the negative 2. Divide by the new exponent is going to be negative 1/2. With this extra negative sign that was at the front, it's going to turn it into a positive. And my final answer was u was cosine of x, the negative 2. All right, that's a perfectly fine answer. Chances are if you saw this in the AP exam, it would look like this, because if cosine has a negative exponent, I can move it back to the bottom of the fraction as the 2 there. So chances are that's the way you would see it. But we make u cosine of x because it's being raised to this third exponent, and just simplifying, remembering the one thing, all right, how negative exponents work when you're doing antiderivatives. Here's another one. It's not obvious because there's no parentheses in this problem, but we have something inside of something else. We have this expression inside the exponent of our exponential. So I'm going to make u equal to 4x squared plus 3. Du is then going to be 8x dx, and du over 8x is dx. All right, so now my expression is going to be 4x squared plus 3 is going to be u, and then dx is du over 8x. And the x's cancel, which is great. The numbers doesn't, but that's fine because then I just put that 1 over 8 at the front of my integral. This is the integral, or the antiderivative I'm most happy to see because nothing changes when I have to take the antiderivative of e to anything. And then I just replace the u with what I know it's equal to, plus c. All right, so exponentials are great ones because when you get to the antiderivative part, there's no work to do. All right, here's another one. This one, super obvious. I hope when you first look at this one, the first thing you should try for your u, maybe you get unlucky and it's not actually right, but the first thing you should think about for doing for u for this one, pi over 2 x cubed. Because it's inside the parentheses of another function. So du is going to be 3 pi over 2 x squared dx. And then let's see, so I'd have 2 over 3 pi x squared du equals dx. All right, so the 2 is going to end up on the top, and the 3 pi and the x squared are going to end up on the bottom. So when I rewrite this expression, x squared cosine of u dx is 2 over 3 pi x squared du. All right, what cancels out? Just the x squared cancels out. So we're going to have this 2 over 3 pi. That's a constant that can just go in front of my integral, cosine of u du. When I take the antiderivative, again, that 2 over 3 pi is just going to hang out. Derivative of cosine of u is sine of u. And my final answer is just replacing that u with, pi over 2 x cubed. So that is my final answer there. And this one, hopefully, now that we've done a few examples, this one's kind of popping out to you that you see something in the parentheses of another equation. That pretty much has to be u. All right, and last one, the least obvious one. This is where you're doing some thinking outside the box. Whose derivative is going to be also in this? So the first idea might be to make u x squared. So let's just do that over here and see what goes wrong if I just make u equal to x squared. So if u equals x squared, because it's inside the parentheses, g here is 2x dx, du over 2x equals dx. All right, doing all that, cancel out my x's, and I get 1/2 sine of u cosine of u. And that's great because I plugged in everything and I canceled out my x's and I got something that has u, but I still have no idea how to take the antiderivative of sine of u times cosine of u, right? This is multiplication, and multiplication has to do with the product rule and stuff, so undoing the product rule is going to be a really difficult process. You actually don't learn it in AB at all. You learn it in Calc BC. All right, so I have no idea how to do this. So this was not the correct choice for u. Right? And that's fine. Sometimes you pick the wrong u and it doesn't actually make your problem simpler, and sometimes it actually makes your problem more complicated. All right, this one just didn't simplify it enough. So if it's not just sine of x, maybe it's just one of these. Let's just try u equals sine of x squared. All right, then du is going to be a chain rule problem. Derivative of sine is cosine. Multiply by the derivative of the inside is 2x. All right, and then I took the derivative of x in that last step, so I get a dx. All right, dividing over, du over all this stuff is dx. All right, so now my actual equation, x is there. I made this u. Cosine of x squared has not changed. And dx is now this complicated thing I found over here. And now a lot of stuff cancels out. The cosine of x squared cancels out, and that one single x cancels out. So I saw that 2 that didn't cancel out, so I get 1/2 antiderivative of u du. Antiderivative of u is u squared, divided by 2 is 1/2. And I can multiply those together to get 1/4 u squared plus c. And then u was sine of x squared, so it's 1/4 sine of x squared squared. And that would be my final answer. All right, so this one, making u the most obvious thing of just x squared, doesn't end up working out. Actually, you could go down to here and then just make u sine of x or something like that, and you would basically get down to here as well. That's a double substitution. Maybe not the direction you want to go at this time. All right, but if that doesn't work, try something else. All right, I tried sine of x and it worked out. If you tried cosine of x squared would also work out. All right, but just be willing to try things if the first thing for you doesn't quite work. All right, so here are some examples. I will just keep doing a bunch of these in class to really kind of drill substitution into our head and kind of what you should be looking for when you're trying to do substitution. All right, but if you can do all of these problems and all the ones that we do in class, then you'll really be able to slay the day.